Welcome back to We Dared Chemistry. In this lecture, we will spend our brain doing some numericals, so join us whether you are a student or a curious mind. In-text questions. Problem 2.10. What are the frequency and wavelength of a photon emitted during a transition from n equals 5 state to the n equals 2 state in the hydrogen atom? We have a following given value. n1 equals 5. n2 equals 2. Solution. From the previous lecture, we know that delta E equals minus 2.18 into 10 raised to the power minus 18 multiplied by 1 upon n1 square minus 1 upon n2 square. Substituting the values in the given expression of delta E, n equals minus 2.18 into 10 raised to the power minus 18 multiplied by 1 upon 5 square minus 1 upon 2 square. After calculation, delta E equals minus 4.58 into 10 raised to the power minus 19 joules. Negative sign shows that it is emission energy. The frequency of the photon, taking energy in terms of magnitude, is given by frequency equals delta E divided by Planck's constant. Frequency equals 4.58 into 10 raised to the power minus 19 divided by 6.626 into 10 raised to the power minus 34. After calculation, frequency equals 6.9 into 10 raised to the power 14 Hz. Now wavelength. Wavelength equals speed of light divided by frequency. So, wavelength equals 3.00 into 10 raised to the power 8 divided by 6.9 into 10 raised to the power 14. After calculation, lambda equals 434 nanometer. Thank you for your attention. Keep studying with We Dared Chemistry.